A particle with initial position vector 2, 0, 1 is moving in space with velocity v of t is equal to negative 3 sine 3t, 6 cos 3t, 0, where t is the time in seconds and distances are in meters. Show that when t is equal to pi by 6, the particle has a speed of 3 meters per second, and determine its distance from the origin at this time. Well, v of pi by 6 is going to be negative 3 sine pi by 2, 3 pi by 6, 6 cos pi by 2, and 0. Cos pi by 2 is 0, sine pi by 2 is 1, so that is negative 3, 0, 0, and therefore the modulus of v pi by 6, which is the speed, is just going to be 3 meters per second. Now, to get r, we are going to integrate. That is going to give me cos 3t plus a constant 2 sine 3t plus a constant, remembering to use the chain rule here when we're, or the reverse chain when we're integrating, and constant 3. And we know that r of 0 is equal to 2, 0, 1. So that tells us C1 is equal to 1, C2 equals 0, C3 equals 1. So r of t is going to be cos 3t plus 1, 2 sine 3t, and 1. And so the distance, not vector, is going to be the modulus of r pi by 6. And so that would be, again, cos pi by 2 is 0, so that top component is just 1. Sine pi by 2 is 1, so that one's going to be 2, and the bottom one is 1. And so we're talking about the modulus of that, so that is the square root of 1 squared plus 2 squared plus 1 squared, which is root 6 meters. If you gave a calculator answer, it should be about 2.45. Determine the angle the acceleration vector of the particle makes with its initial position vector when it is first 2.5 meters away from the origin. So the modulus of r of t is going to be the square root of cos 3t plus 1 squared plus 2 sine 3t squared plus 1. And we want when that is equal to 2.5. So we're just going to solve on the cas, and that should give us t is equal to pi by 9. Now, to get the acceleration, we're going to differentiate the velocity. That is going to be negative 9 cos 3t, negative 18 sine 3t, and 0. And a of pi by 9 then, remember these are 3s, so they'll end up being pi by 3 inside each of those. That is going to be, so negative 9 times the cosine of pi by 3. Cosine of pi by 3 is a half, so that one's negative 9 over 2. And in a similar way, this one is negative 9 root 3, and this one is 0. And so we have the acceleration at that time dotted with the initial position vector, which is 2, 0, 1. And that must be equal to the square root of negative 9 on 2 squared plus negative 9 root 3 squared, root 5 cos theta. We're just using a dot b is equal to mod a mod b cos theta. So there's your a dot b. That's the modulus of the first vector, modulus of the second vector, and cos theta. And again, we can just solve for that. And it should give us 104.4 degrees.